Greetings, gentlemen. Welcome to the Smart Video Lab. I'm here with the Unit 5 test review and specifically looking at problem 4 right now. I'm not going to do all the problems remaining on the test review in this video, but I'm going to do a few that I think will be very helpful to you. So looking at number 4, it says two exponential growth and decay situations are represented by graphs 1 and 2, and also by tables A and B. For each graph, there is a matching table. Part A asks us to write the number of the graph besides its corresponding table. So let's look at the first table, table A. The y values start at 6, and they're increasing by a constant multiple of 2. 6 times 2 is 12, times 2 is 24, times 2 is 48. So we know that that's exponential growth, right? Anytime that we're always multiplying by a constant number, it's exponential growth. So we said it's increasing exponentially. Which graph looks like it's increasing exponentially? That's right, graph 2 is increasing exponentially. Now looking at table B, it's decreasing, so it has to be graph 1 because graph 1 is decreasing exponentially. So now we want to write a rule for table A. So this is very important to remember. We know it's exponential growth and exponential decay, so we have to remember rules for exponential functions. So exponential functions always fit this structure, a times b to the x, where a is the starting value, and b is the common ratio. Now if I look at table A, remember when we say the starting value, we're specifically talking about the y value when x is 0. So in other words, the y-intercept, or where it starts on the graph at x equals 0. Problem is, in this table, I don't have the value when x is 0, so I need to add that in. So if I continue the pattern, 24 down to 12, we divide it by 2. Divide by 2, you get 6. So if I divide by 2 again, I'm going to get 3. So the starting value here is actually 3. So my rule is going to be y equals 3 times something to the x power. Now what goes in that parentheses? The common ratio. What are we multiplying by every time as we go from one term to the next in the y values? And yeah, we already said that earlier. That's 2. Now looking at the next table, again we have to add in the 0 value for x. And let's see if we can figure out what's going on from term to term. And this one's a little harder to tell, but it's actually multiplying by 2 every time if we go backwards. So this 1.5 times 2 is 3. So this rule is also going to start with y equals 3 times something to the x power. Whoops, sorry for jumping there. So now if we look at going in this direction, the typical direction that we think of, we're actually dividing by 2 every time. But remember, we said we want to write that in terms, instead of saying we're dividing by 2, we want to write that as multiplication because common ratios talk about multiplication. So dividing by 2 is the same as multiplying by 1/2. So this is 1/2 that we're filling in for our rule there. All right, now for problem 5, it says use properties of exponents to write each of the following in a simpler equivalent form that uses only positive exponents. Now we're going to do that, but I want to do it by first pulling up a separate window. So let's look right here at this first question, question A. We've got b to the 4th divided by b to the 2nd. So remember, when we divide exponential expressions with the same base, we subtract the exponents. So that's b to the 4 minus 2, which is b squared. Now you're asking, why does that work? Well, what does b to the 4th mean? B to the 4th means b times b times b times b over b squared. What does b squared mean? B times b. So if I look, b over b simplifies to 1. B over b simplifies to 1. So I'm left with just 2 b's. And b times b is b squared. So that's a kind of a proof of why we got that answer. Now part B, we've got 6x over 5 squared. And for this one, I want you guys to just think about, what does it mean to square something? Well, let's go over into our thought cloud. What does 2 squared mean? That's right, 2 times 2. What does x squared mean? Yep, x times x. So 6x over 5 squared just means 6x over 5 times 6x over 5. Now we just multiply. 6 times 6 is 36. X times x is x squared because we add the exponents, and 5 times 5 is 25. So that's our answer there. Now part C is similar to part A. We are dividing 18x to the 6 divided by 3x cubed. So 18 divided by 3 is 6, and then x to the 6 divided by x to the third is x to the 6 minus 3, which is 2. So 6x to the third is our answer. Now for part D, we've got 8 over x to the negative second power. So we have to think about, what does it mean if I have a negative power? Remember, we said that that means you move it to the denominator and make it positive. So x to the negative n, we can think of that as over 1. Any number is always over 1. Nothing's written. So that becomes 1 over x to the n. We moved it to the denominator and made it positive. Similarly, if I start with 1 over x to a negative power, we move it to the numerator and make it positive. And you can think of that also as being over 1, but usually we wouldn't write that. So part D here, 8 over x to the negative second. To make that exponent positive, we have to move it to the numerator. So this becomes 8x squared. Moved it to the numerator and made it positive. And you keep the base and the exponent together always. We're keeping these together. Now question E is related because it asks us to find 3t to the negative second power, which is, again, if I apply the same logic, we move it to the denominator and make it positive, 1 over 3t squared. So now let's think about in the cloud over here, 3t squared means 3t times 3t. 3 times 3 is 9, t times t is t squared. So that's 1 over 9t squared. Now part F, 6xy to the negative first. Important distinction here, we want to simplify this with no negative exponents. So what we're really worried about is this negative exponent with the y. Notice the exponent on 6 is positive, it's 1, and the exponent on x is positive, it's 1. So the negative 1 only goes with the y. It would go with everything if it was written this way, in parentheses. But the negative 1 only goes with the y. So we just have to move this term to the denominator and make it positive. So it becomes 6x over y. Now last one, we've got negative 5x cubed squared. So again, what does it mean to square something? We multiply it by itself. Negative 5x cubed times negative 5x cubed. Negative 5 times negative 5 is 25. X cubed times x cubed is x to the 6th. And that's it for this video. I might be able to make one more with a couple other problems. But if you watch this video on your test when you take it, next to your name, you can add to your code stick. So in the other video there was one word. Now for this video, the word is stick. That'll get you 1 extra credit point on your